Welcome. In this lesson, we will be learning about measures of dispersion. A measure of dispersion is a statistic that describes how far apart the observations in a given data set are from the central value. The central value may be the mean, the median, or the mode. There are three major measures of dispersion, and so they are very common, and they include the variance, the standard deviation, and the range. Okay. We also have the coefficient of variation. The coefficient of variation is useful, but may not be as common, or rather it's not as common as the other three. Okay, so the variance can be obtained. Okay, so now the variance is the sum of the squared deviation of the observations in the data set. So you can obtain it using this formula, the formula you see here. And when you get the square root, then it becomes what we call the standard deviation. All right, let's take an example. Supposing our data set is actually what you see, 2, 3, 4, and we decide to obtain the mean. So the mean is going to be 3. And when we have the mean to be 3, then we can take the first observation and say 2 minus 3, that's the first observation. So that's what your formula, the formula we are using, or we are going to be using. Okay. Just want to bring it down here. I think making this red, for instance, will really help us. Okay. So you can understand that it's not part of this. All right, so now the formula here is saying that take each observation and find the difference between that observation and the mean and square that difference. So that's what we are doing here. Observation, so 2 minus 3 squared plus 3 minus 3 squared. Okay, so the next observation is 3. And that's what we are doing here. So we take 3. The mean is 3. So remove 3. Then we take the third observation. So don't forget we are squaring that. The third observation is 4. So we say 4 minus 3. Okay, sorry about that. Then we say 4 minus 3, and then we square that again, and or we square that, and then that way we can have 2 minus 3 to be minus 1, and then we square that. So 3 minus 3 will be 0, square that, and then 4 minus 3 will be 1, we square that, and then we are going to have 1 plus 0 plus 1, and that becomes 2 divided by 2, and we have 1. So the square root of 2 happens to be 1. All right, so that means our standard deviation, which is represented by S, is going to be 1. So the variance is 1 and the standard deviation is 1. All right, please take note. What we have here is actually what we call the sample variance. So the sample variance is what you are seeing. Now, but we have what we call the population variance. We represent that by sigma square, and that will be defined as x minus mu. So square, we square that, and then we divide by capital N. So don't forget, capital N is your population size. Okay, that's if you knew that before. You did not know that, then capital N is actually the population size, so population size, and small letter n is actually your sample size. Where is small letter n coming from? You may have a population size of maybe 1,000, and you decide that you just want to take maybe 300 out of them to study. In that case, n will be 300. So that's what we're talking about. All right. So that being said, we go to the range. Now the range is the difference between the maximum and minimum of the observations in the data set. So let's assume that our data set is what you are seeing, 2, 3, 4. Then the range will actually be 4 minus 2. Why? Because 2 is the minimum. That's what you are seeing here. And 4 is the maximum. And that's what you are seeing here. So range becomes 4 minus 2, and that will give us 2. Okay. Now, there are other measures of dispersion, which include everything you are seeing here. But for now, we'll not be discussing them. We'll be discussing them in a subsequent video. That should be the next one. That should be the next one. Okay. Now, they follow the range or the same pattern with the range, but this time you are going to be obtaining something we call A, another thing we call B, and then when you obtain them, you find the difference between them. And in the case of the interdecile, percentile, quartile, it's just going to be A minus B. But in the case of semi-interdecile, percentile, quartile, like that, the range that you obtain for these ones will involve A, or will be equal to something that you call A minus another thing that you call B and divided by 2. So actually it will not be A and B, but I'm just using this to illustrate it for now. So if you don't understand this, don't worry, but it will be explained in detail. It will be explained in a way that you can understand in the next video. All right, so we'll move on to the next thing. So there is another less common measure of dispersion. Now, it's not like it's not appearing in literature, but it may not be as used, or rather it may not be used frequently, like the variance, the range, and the variance, the range, and the standard deviation. So, all right, so we call it the mean absolute deviation, or you may just say absolute deviation from the mean. So now it involves, rather than squaring, what we're doing when we're using the variance was x minus x bar, so raised to the power of 2 minus n. But this time around, we will not square, but look for the absolute value. So just the absolute value. That's what you're seeing here. All right, so we look for the absolute value of the difference between each observation and the mean. All right, so if we do that, then we are going to have something like what you are seeing here now. So the observations are 2, 3, 4, 5, 6, 6, 7. So you say 2 minus, the mean happens to be 4.7142. So if you do that, that's what you're going to get. And the median is 5, the mode is 6. So using the mean, 2 minus 4.7152, the next observation is 3, you remove the mean from that. 4, you remove the mean from that. 5, you remove the mean from that. 6, you remove the mean from that. You do that for the next 6. And then finally 7 minus the mean. So when you have done that, these are the results. These are what you, okay, you'll be getting this actually. And so you now decide to get the absolute values of the results. So what are you going to have? The absolute value thing says when you have a positive number, you get the absolute value by writing, okay, you put the number in these two lines that you're seeing, and then you have A. So if you do that for a negative number, you're also going to have A. Why? The reason is because the square root of A, okay, when you say absolute value, what you are saying is square the number and look for the square root. So when you do that for a positive number, you get the same number. And then when you do that for a negative number, when you square it and you get the square root, then you get the positive version of that number. So that's what we do when we say absolute value. All right, so when we have done that, we are going to have 10.2858 divided by 7. and that eventually gives us 1.4964. All right, so going on, we have our mean absolute deviation to be 1.4964. Nonetheless, what about a situation where we did not have the original, maybe somehow, we may even have the original data, but maybe we can't use the mean for one reason or the other. It's also possible to use the median and the mode. So if you like to use the median and the mode, you can do that. And what you're going to have when you use the mode, so in this case you call it the absolute deviation from the mode, not the absolute deviation from the mean. And you should, okay, so that way it will give us this. And if you decide to use the median, we are going to have this. In that case, you are going to call it the absolute deviation from the median. All right, but in literature, actually, this is what you see, the absolute deviation from the mean. So that's what you see. That's what is common. That is what is actually ideal. Okay, that's the ideal thing. But in some situations, if you may want to use the median or mode, it's possible. All right, so we move on. Now, just like in the case of the absolute deviation from whether the mean, median, or mode, we can do that. Now, I want you to know that the variance is actually called the squared deviation from the mean. The variance, okay, is the sum of the squared deviation of the observations in the given data set from the mean. So, in other words, you may call it the squared deviation from the mean. Squared deviation, look at that, squared deviation, okay, from the mean. All right, so going by that, we may refer to, or rather we may use the mode in place of the mean in our formula, and this is what we are going to have. And we may use the median in place of the mean, and this is what the formula will become. Nonetheless, I want you to know that what is ideal when you say you're looking for the variance is to use what we call to use the initial formula, this one, so where you use the mean actually and not the median or the mode. Okay, so but it's so somehow you may use the mode or the median, but if you do, this is what you're going to have. All right, this is what you're going to have. So we can look at another one when we decide to look for the square root of this. So we may have, okay, the square root of what you have here, these ones, then we will eventually have some alternatives for our standard deviation. What do I mean by that? The standard deviation we talked about the other time. So that's it. That's just it. But the standard is to use this one as the variance and to use this as a standard deviation. So please take note of that. If you're not told to do, to substitute the mean for, to substitute the mean actually, maybe using the mode or median, then use the mean so that you can have what we call the variance and the standard deviation. So that's just that, or rather that's that about that. Okay. Now, okay, let's obtain the following now. But before that, let's look at the coefficient of variation. All right, so this is how you define what we call the coefficient of variation, and it is actually to say the standard deviation divided by the mean multiplied by 100. So this is another way to write your standard deviation. I think it's okay to show that SD of X equal to S, and that means your standard deviation. Please, this is what you refer to as your standard deviation. So let's quickly do that. Standard deviation. Okay. And you may have it this way. Sometimes some other persons may, or some people may like to have it this way. Okay. And you refer to this as your variance, and sample variance to be precise. Okay, so please take note of that. All right, having known the definition for our coefficient of variation, we are set to look at the example. Now, so we are told to obtain the variance, standard deviation, absolute deviation from the mean, median, mode, the range, the coefficient of variation. Okay, and these are okay. So our result follows. Let's look at the solution. Now we can obtain the mean to be this. So when we have that, we go on and using the same technique that we discussed about earlier. So you subtract the mean from each of the observations. So for each observation, find the difference between that observation and the mean, and then square that. That's what we're doing here. So the first observation, as you can see, is 2. So you say 2 minus the mean, so, and you square all of that. Then you go to the next observation, it's 1. You say 1 minus the mean, and you square all of that. And then you go to the next observation, that is 2. But I don't have those ones here. I put what we call the ellipsis to just show that, okay, the series continues until you get to the last one. So the last observation is 5, and that 5, you subtract 3.375 from that, and you square. So the last observation is 5. There's another 5, but all of these were not actually explicitly written here. I used the ellipsis to show that it continues, but I did not write them. All right. Nonetheless, if you are using this particular method and your observations are not many, 1, 2, this is 8 actually, you can still write everything. You should still write everything. But if your observation is maybe getting up to 10 or more, you may not write everything. The first 2 and the last one is sufficient to show it. Okay, now, all right, don't worry about this in red. This is just to show so that we can see the data set. All right, now looking at this, okay, when you add everything and then you do your division, you get 4.2679. But I may not really like to go by this formula. The formula you're seeing, this one, when it is expanded, will eventually give us what you are seeing below. So actually, S square, being this, when it's expanded, will give us what you are seeing in green. Now that we know that, I want to take advantage of that to make my work easier, because having to find the difference between this and this when you have so many observations may be difficult. But I can use this to obtain my variance when I have even an observation of 100. It's going to be easy for me somewhat, okay, at least compared to this, using this method, using this formula. All right, so what do? I just need to square each observation in my data now. So each observation will be squared, and added to the next one. So it's a series, and then when you do that, you will eventually have 121. Okay, now 8 is coming from here. N is 8. I have 8 observations, so that's the size of my sample. Okay, the sample size. And then 3.375 is actually my mean. So I square that too and multiply them, and that will give me 91.125. All right, so going by that, I can continue, and eventually I'll have 4.2679 as before. Okay, now, so, all right, I think you can actually see this, that summation x square is actually squaring each of, okay, of the observation and then summing everything together. Okay, I think I explained this earlier. So that's that about that. So we'll go to the next one, the standard deviation. So the question says obtain the standard deviation. And so the standard deviation is the square root of the variance, and that will give us 2.0659. So don't forget, variance is this, and when we look for the square root, we get the standard deviation. Now, so the mean absolute deviation from the, or rather the absolute deviation from the mean, that will give us what we have here. So you can follow each observation minus the mean, and then you get the absolute value. For instance, the absolute value of 2 points, so when you say, okay, 1 minus 3.375, it gives you minus 2.375. And then when you look for the absolute value, don't forget, I did that earlier. Okay, I think it's not here. Then the previous one, the absolute value of a negative number will give you a positive number, and the absolute value of a positive number will give you, the absolute value of a negative number will give you back that number, but the positive version of that number. So minus a, for instance. So absolute value will give you a. The absolute value of minus 5, for instance, will give you 5. And the absolute value of a positive number will always give you back the same positive number. So going by that, we can obtain what we want here. Okay, so the absolute value of minus 2.375 will eventually become the absolute value of minus 2.375, okay, will still be 2.375, yes, but the minus is gone this time around. You don't have it again. You don't have it. Okay, so then when we have done that to all our numbers, we add everything and we get 11.75, and we divide by 8, and that will be 1.4688. All right, so going on, okay, this time around we decide to say, okay, we want to get the absolute deviation from the median. All right, so the absolute deviation from the median will, okay, the median, what's the median of our data set? So using the approach that, okay, so we can obtain the median by, you just say, okay, we have 8 observations, so 8 divided by 2, that will be 4. And so the 4th and 5th observation divided by 2, and that will give us 2.5. So this is the 4th observation, and this is the 5th observation. So that's why we are adding them together and dividing by 2, and that will give us 2.5. Okay, so that being done, we decide to look, going by a similar, okay, like just similar to what we have done here, but this time around we use 2.5 in place of 3.375. So because we are looking for the absolute deviation from the median, and when we are done, we eventually obtain 1.5. Now, if we go to the next one, let me get a question. The question says, obtain the absolute deviation from the mode. So when we do that, the mode happens to be, what's the mode again? The mode happens to be 2. So How did you get that? Look at the data set again. 2 appears twice. Okay, I think there is a mix-up somewhere here. This observation happens to fall, or this question, sorry please, this data happens to be bimodal, okay, or trimodal actually. So it has three modes. Sorry about that, but I've used one of them as the mode. But when you are told to obtain the mode, usually, perhaps, depending on what you want to do. All right, so, okay, usually you'll be given just one mode. So one of the observations will appear more than, or like have the highest frequency. But in this case, so I've used two anyway, but let's just take it that way. All right. Okay. So using a mode of 2, we will eventually obtain our mean absolute deviation to be 1.625. So that's that about that. And our range will be 5, so using the formula there, and the coefficient of variation, just dividing your standard deviation by the mean. So the standard deviation is 2.0659, the mean is 3.375. So you do that, and then multiply by 100, and that will give you 61.2119%. So that's that, or that's it. All right, so so far we have looked at the variance, standard deviation, coefficient of variation, range. So let's look at what the mean tells us. The mean is a representative value, and I've used the blue marker here to denote the mean. So the mean. Now, the variance tells us how far apart the observations are from the mean. So imagine that, or just assume that the red markers are actually all the observations, but the blue marker is the mean. So you can see that these observations are close, but not as close. The observations in case 1 are not as close as those in case 3. So, and then the observations in case 2 are very far from the mean. So these ones are close to the mean, but not as much as these ones are to the mean that they have here. So now, looking at that, we consider the variance, how far the observations are from the mean. So it means that, evidently, looking at this, the variance that you have here will be less than the one you have here, and the one you have here will be more than the one you have here, and the one that you will have here will be more than what you are going to have here. So let's look at that now. So the variance calculated for case 1 is 1, for case 2 it's 212.3319, and for case 3 is 0.01. And when you go on, the coefficient of variation is 33.3% here. It is 99.3%, or rather 99.35% here, and then 4.7619% here. So it means that even if you were not able to get the full data set, once you see the coefficient of variation for all three, you will be able to tell that you'll be able to tell that observations for case 3 are closer, okay, or the observations in case 3 are actually closer than those of case 2 and case 3. Okay, and then the observations in case 1 are closer. Case 1, I mean this is case 1, are closer than those of case 2. So, all right, and that means that they are close. These ones are closer to the mean. The observations from case 1 are closer to the mean than the observations from case 2, whereas the observations in case 3 are closer to the mean than the other two cases. So than the observations of the other two cases are to their respective means. So that means that it's very useful to know your variance and the coefficient of variation. So that being said, let's just quickly do a recap of what we meant by measure of dispersion again. Now, measure of dispersion is looking at how far apart the observations in a given data set are. And so we need to have a measure of central tendency. In the case of your variance, when you're looking for the variance, you need to know that in order to obtain it, the standard deviation as well as the coefficient of variation. So if you want to obtain any of these three, you need a measure of central tendency. Nonetheless, we have the range that does not need that. So you just need to know the maximum and the minimum to obtain your range. And we also have the interdecile, semi-interdecile, and the others that we discussed. Those ones, you do not need a measure of central tendency here to obtain these ones. But if you're going to obtain the last one that we discussed, which we call the absolute deviation from the mean or from the median or from the mode, or so those ones like that. If you are going to get the absolute deviation from the mean, median, or mode, you also need the central value. All right, so that brings us to the end of this lesson. Thank you.